Okay, so today we're going to talk about a couple different plots and kind of getting into what plots are and which ones we use when and that kind of stuff. So our first one is a line plot. And line plots are a graph or plot that uses x's to show data on a number line. Okay, so I would start with a number line, and obviously we would, like some numbers on it. You don't just want to start plotting things all over. Okay, and then let's say our data set, it has 1, 1, 1, 2, 3 3s, 2 4s, a 5, and then an 11. Okay, and of course we want to do a title of some sort, describing our data. So maybe it's how many pets you have at home currently. So many people have 3 pets. Somebody apparently has 11. That's a lot, but okay. So we're going to notice a couple things about our data. The first thing is a cluster. And a cluster is when the x's are close together. Especially if there's a lot of the x's close together. So most of our data here is clustered at 3 and 4. I have 3 on 3 and 2 on 4. That's more than any of the other ones, and they're right next to each other. So 5 of my data sets lie on these two numbers. You could do a wider cluster, which would be 1 to 5, but usually with as many x's there are on 3 and 4, we would say our cluster is there. We also have a gap. A gap is where no data occurs. So there's a gap from after 5 to all the way before 11. So all these numbers have no data points. And then we also have what is called an outlier. And an outlier is set apart from the rest of the data. So 11 would be our outlier because it's so far from where the normal ones are. Okay, so that's line plots briefly. The next thing we want to talk about is stem and leaf plots. So let's say we're looking at the building heights in Dallas. Just as an example. And we have a building that is 40 stories, 30 stories, 28, 24, 37, 31, 24, 28, 32, and 37. So we could definitely do a line plot and graph these data points. You could, start your line, your number line at 20 and go to like 40 something, but that's a lot of numbers on a number line. So another way we could do this is a stem and leaf plot. So I draw essentially a T-chart, and I have my stems on one side and my leaves on the other. And with this data here, they're all 2 digits. So my tens place is going to be my stems. So I have stems that start with 2, 3, and 4. And then my leaves are going to be my ones place. If I had numbers in the hundreds, I could use the hundreds as the stems and the tens and the ones as leaves. I could use the hundreds and tens as the stems and the ones as the leaves. It just kind of depends what my data looks like. So then I start writing the leaves in from least to greatest. So I see that my lowest number is a 24. I have 2 of them, so I'm going to write the 4s twice. I also have 2 28s, so I will write 2 8s. In the 30s, I have a 0, because that's 30. I don't just leave it off. My leaf is actually a 0. I have a 31, so I write a 1. I have a 2, and I have 2 7s. And then for 40, I just have a 0 leaf. So I can see very easily most of my numbers are in the 30s. If I was looking at modes, my mode would be 24, 28, or 37. And we don't just read it as 4. We read, like, if it's 2, then the line, then 4, we would read this as 24. I could also get my median pretty easily now that they're arranged from least to greatest. So this kind of just helps organize our data, look at it in a different light, and kind of, especially if I'm just looking at, how slightly different things are, the ones column gives me a better look at that than maybe the tens. So stem and leaf is another kind of plot. Our third type of plot today is called a histogram. And histograms are a type of graph or plot that show frequency of equal intervals of data. So, before we start making one, let's look at the steps on how we would make one. So we're going to use a frequency table, and we'll look at what one of those looks like in a sec. And that will help us choose and label a scale on the vertical axis. We will label the horizontal axis with the intervals the frequency table provides. And then we draw bars, much like we would on a bar graph, except for these have no spaces in between them. And those bars show frequency. Okay, so that's a lot of words, but let's see what it means. Okay, so let's say I measure the height of my 7th graders. Okay, in inches. And I have a 52, 57, 59, 59, 50, 59, 51, 52, 49, 60, 56, 50, 55, 58, 53, 52, 51, 54, 50, 54, 53, 58, 57, 67, 55, 57, 58, 56, 57, 58. I know that's a lot of numbers to write, so just make sure you have them down. So the first thing is a frequency table. And so if we've never seen a frequency table before, here's kind of what they look like. We have 3 columns. The first one is our raw data, so our heights in this case. And then we'll have a tally column. a frequency column. And sometimes we even have a cumulative frequency. Okay. So usually it'll break it down into ranges for you. The important thing is that the range is always the same number of the intervals of the range are the same, is I guess a good way to say it. So from 49 to 52, that's anything that's 49, 50, 51, 52. So 4 numbers big. So then 53, if I include 53, 54, 55, it would go to 56 would be my fourth one. 57 to 60, 61 to 64, and then 65 to 68. I probably don't need to go above that for this one. If I look back at my raw data, I can start doing a tally. So there were this many people if I'm tallying it. And obviously I'm going in order because I have my chart done. But if you were just copying the raw data, you might hit 52, that goes in this one, and then it's, 67 or something. So you can kind of do the tally as you see them from your raw data. Once you have the tally down, we go to our frequency. So this one has 9 tally marks. This one has 8, 12, 0, and 1. The cumulative frequency, the way that works, well, this one starts at 9, okay? That's how many people I have so far. Then, after this, I add these 8. So 9 plus 8 will now give me 17. So I'm going to add these together and bring it over. So 17 plus 12 will give me 29. Plus 0, I'm still at 29. And then plus 1 will give me 30 in my cumulative frequency. Okay? When I go to make my actual histogram, I'm looking at that frequency table to pick my scale for my horizontal axis. So if I go back and look at it, my frequencies are 1 to 12. So I probably don't want to count by 1s. I probably want to count by 2s. So I'll go over here. I start at 0, 2, 4, 6, 8, 10, 12. And then across the, and I'm going to label that obviously frequency. Across the bottom, I'm going to put those ranges or intervals I had. So 49 to 52, 53 to 56, 57 to 60, 61 to 64, and 65 to 68. And then I can start drawing my bars. So for 49 to 52, I had 9 people, so that would be here. My bar goes all the way across because that's the number of people in this interval. Okay, it's not just one number, it's the entire interval. From 53 to 56, I had 8. So again, there's no gaps in between. It goes all the way across. From 57 to 60, I had 12. I'm going to go up to 12, bring it back down. I didn't have anyone in 61 to 64, so there will be that gap in the data there. And then I only had 1 in 65 to 68. And we can color these in or shade them in as we need. It doesn't have to be super pretty or anything. And sometimes they shade them and sometimes they don't. It just kind of depends what you want to do. But that is a histogram.